Moon's surface. Again, like Earth, we think about what's inside. We think about all those things that we know about it. And we know quite a lot about it, right? Without getting into any more detail. Hey, what's that white spot down on the lower left? What are the dark areas? What are the light areas? Some people would see this as a rabbit with ears here, a rabbit, and some people say a honeypot. Again, people make up stories and whatever. Some people say a face. With the right light and the right maybe sunglasses, you can see kind of a face with big round eyes and maybe a mouth or something like that. And what's this feature? Okay, light areas, light color areas, dark colored, if you will, areas, and that feature. We're going to study that. What's on the other side? That's the side that presents it to us. Remember that we only one side faces Earth all the time as it orbits, continues to spin and face Earth. That's the side. What's the other side look like? We'll take a look. Let's come over here, study it. So this is what we're up against. Let's do that. Coming over here, what are we going to do? Well, we're going to use Earth as our guide, right? So we're going to use Earth as our guide. So let's look at the 4 ways Earth's surface changed. So we're reviewing as we're learning new and putting it together. We'll be able to do Mercury, Venus, and Mars really fast. You'll see it'll all make sense. And you'll even be able to guess. In the book, I've got a place for you to guess. Try it, be bold, and guess what's going on in terms of the layers of each of those worlds. All right, any erosion on Moon? We saw the surface. Any erosion would we expect? Is there any gas or wind? Any atmosphere? No atmosphere, right? But, so the answer here is a big no, except what kicks up the dust? Except solar wind. So let me just say solar wind. Solar wind can create some erosion. So we've got no blanket of atmosphere, and we've got no magnetosphere, and so the solar wind does create some erosion, not atmosphere wind, but solar wind. Any liquid, rivers, any rain, no, we don't even have an atmosphere, and there's no liquid, the water would vaporize, etc. So no, and I'll talk about that a little bit. Any glaciers, any solid, no erosion. So things stay as they are pretty much, right? They haven't changed much. A little erosion from solar wind. Now, what about water? Let's talk about water. Liquid, rain, etc. You don't see oceans. So those dark areas that you just saw, they look like oceans. In fact, the name is Latin for seas. They look like seas, but they aren't. Okay? However, there is more water in ice crystals within the rocks and within the craters and than you might think. And that's very important for space exploration because we need hydration. I mean, you know, how many water bottles do you need to bring up there to live up there for a couple of weeks or however long you're going to stay if you have a space station? Where are you going to get your water? And so there's that. And also, water can be used as a source of energy. So luckily, there is a way to extract that water. So let me just say more ice crystals than you would expect. But it's not a lot, but there's a method, and it's doable. And of course, you use all that sunlight, right? Solar power up there. So just know that about water, and you can explore more if you want. Okay, what about volcanism on the moon? Any volcanic mountains? We're going to see volcanic mountains elsewhere, but the answer here is going to be a big no. Not on this world. Other worlds, we'll see. Not on this one. What about any past volcanism? Remember that? Remember that as our solar system formed, which we're getting to right next thing, chapter 7. Yes, moon was hot. Right? When things form, they're hot. But it cooled. Right? So we know that it's cooled. And so this is an important point. Let me do it in red. Lava seeped through the surface, especially where the crust was thin or lower and it came out. And that could be related to the heating of that rock through radioactive materials. There's a factor of the tidal effect at play. We're going to mention that a little bit. Various things, but remember this: lava seeped through. So that's a big, important fact here. And the next thing is we're going to say, well, what about present? And the answer is no. No volcanism now because it's cool, right? Okay. So not much erosion, a little solar wind, kind of parenthetically. Lava seeped through tectonics, moving crust. Any moving crust even might not be in plates, but some motion of the crust. Usually that's right. You know why that? It's motion from below. Well, do we see any tectonic mountains? No. If you look up close at moon, there are no mountains. No tectonic mountains. There are no volcanic mountains. What people refer to when they talk about mountains are really the edges of craters, which we're getting to. Okay, so there's no tectonic mountains, and there's no convection, the hot rising, cooling, sinking in the mantle that we have on Earth. No. So what you have is you see an old, unchanged surface, except for the little bit of solar wind and the lava that seeped through. This is the primary thing. And we're going to see that. And so the impact craters, a lot in the first billion years, still stuff flew around, so there's more recent than that too. So this world is dominated by impact craters and areas where lava seeped through. And in fact, that's what you see when you see the light and dark areas of moon. It's pretty simple, actually, when you get used to it. So let's give that a look. Now this list is in the book. The light areas and the dark areas. Let's go back over. There's the light areas and the dark areas, right? Just look on the web. It's nice and free, and that's pretty cool. All right, what are they? What am I looking at? Tell your friends. Well, the light areas are called the Highlands. The dark areas are called the Maria. The singular for Maria is mare, of the sea. Del mar. If you order something at a restaurant, Del Mar, you're ordering something from the sea, seafood, right? The light-colored areas, or the highlands, are most of Moon's surface, so you should know this. Most of Moon's, just look at a picture and notice, most of Moon's surface is like this, you can see. The far side, which I have not shown you yet, and you can easily look that up, is almost all highlands. It's almost all light, not much of that dark stuff. And what is it? It's heavily cratered areas. And these heavily cratered areas, as you know, if they still show, well, they haven't changed much. We call them old because they haven't gone through much change. They're all formed together with the solar system, chapter 7, coming right up. But they haven't changed much. Okay? And in those cratered areas, when things came in and smashed into the surface, smashes with such velocity, comes in with such velocity that it pulverizes that which it hits and itself into a big fine dust. That top layer of powder was called regolith. In fact, people were wondering, if you land on moon, would you sink? And I think there's science fiction, talks about that. And so what do? Do you just go land on there and see? No, you land something else, right? You throw a toaster on there or something, see what happens, and you explore that. And the Soviets were ahead in doing that. They first a crash land, first a soft land, etc. All right, but when you do walk on moon, it becomes quite interesting. Something quite interesting about that powder. Now, some of the hoax folks, you gotta know what you're talking about before you start just making stuff. Just because it seems right doesn't mean it's right. That's why we do science. I mean, you can have a notion, but then dig deeper. I mean, do the work, right? So the hoax folks, they go, oh, well, we know moon is dry, so you can see footprints. You can't see, if you step with a boot in dry sand, the sand fills it in. You take your foot away and the sand just kind of rolls in, fills in your boot print, doesn't stay. So you kind of know that. And yet, the moon is supposed to be dry, and you step with a boot, and the footprints, you see all these footprints around the lunar lander, right? So, what's up? In fact, hoax theorists, that shows you it wasn't. If moon landing was faked, they were able to do things that you might be able to do now with Photoshop and everything that you can do. But you would have had to figure out that moon footprints would stay on a dry surface, because what's the difference between Earth and moon? Earth has erosion, wind from an atmosphere, water. What happens to the sand? It becomes round little ball bearings, little round things. So you step in sand and it rolls into it. On moon, hasn't changed, has it? No atmosphere, little solar wind. And so this regolith is jagged little particles. If you want to simulate that, have a barbecue, celebrate. 4th of July, closest to sun, yay, right? So perihelion. So take your charcoal powder, put it on the ground, make a pile, step in it. That charcoal powder is jagged like this, and your boot print will stay. Of course, on Earth, the wind will sweep it away. So footprints stay because of the lack of erosion of that. So yes, and that big crater, that big spot I showed you on moon, it's the one feature that I might ask on an exam. I ask some things, not others sometimes. It's called the Tycho Crater, and you know Tycho Brahe. So now, because we studied in chapter 3 some key figures in history, we can see some of the names of moon. In fact, a lot of the moon craters are named, and Maria are named after people like Aristotle and Archimedes and Galileo, etc., Copernicus. So you know all those names. Okay, so that's what the light areas are. Heavily cratered, mostly on the far side, powder, boom, got that. And you got a feature by name. Number, the other part over here, cool, we're good. Part of Maria, and I'm going to take you on a tour to finish this up, a little slide tour, which you can easily see on internet. The darker areas, most are on the near side, yay, making it much more interesting. Remember, where's my face? But what do I do with it? Oh, here it is. One side always faces us. Well, that dark area that faces us, and we can see a rabbit or a face or whatever, is the mare, or Maria for plural. And the back side is boring. It's mostly all white. I'll show you that. It's the cratered area. Why is that? That's interesting. Watch Direct from the Moon by National Geographic. Okay? And you get a visual of that, and sort of a sense of that, but I won't ask it. Most of the Maria are on the near side. They have names too. Sea of Tranquility, or you can say it in Latin if you want. Sea of Serenity, and so on. What are they? wait a minute. Do you see how this ties with what we just did? What did we say is on moon surface? Craters and lava that seep through and quickly solidified. So lava, right, which is liquid rock, seeped through. So oceans, well, of liquid rock, but it just quickly solidified. It's dried, cooled lava. And that seeped through after this period of heavy bombardment. Now you do see craters in those areas that came later, but that seeped through after that period of heavy bombardment. So we would call this a younger surface because it changed after around the first billion years, and I'll let you look that up and be picky about it if you like. And there are names there too, but that could be a little bit much to deal with. So there you have it. That's our moon, our backyard, right there. Go up, have a picnic, come back. All right, let's take a look. Let me get this, finish it off. All right, now you know. Do a little review. Maria, Highlands, Tycho Crater. Go out, get some binoculars, see if you can find Tycho Crater. Depends on the phase, right? So let's do this. We know it's got phases. We know the same side always faces us. We know the near side is the side that faces us, and that's where most of the Maria are. Check it out. Ah, far side. Pretty boring. Lots of highlands, little Maria. Lots of highlands. Right. Near side. Yay, interesting. Right. Waxing crescent. Venus. We're going to study Venus. What's up with Venus? We need to know its size and distance and all that stuff. Eclipses, right? Landing, yes. It's beyond silly to say it was a hoax or beyond ignorant. Let me just say here that because of a lack of atmosphere, right? When sunlight comes in, it's not being blocked. It's incredibly bright. So it was well known, and you can see articles before they go, you're talking about it. You know, if anybody wants to really pay attention, you've got to have very fast film. If you're on snow or sand and it's very bright, you got to go fast open, you know, if you're using film. And now, of course, we're not. But you can't expose it very long or everything's going to be blasted out. So if you exposed it long enough to see stars, this would all be blasted out. Look, there are footprints. Ha, that makes sense, right? So, is this colorized? Yeah, that looks colorized to me because it's kind of got a brownish to it. So you can tell things, and we check each other. So, da-da-da. There, that's more, you see color, but over there, they were struck when they landed by how colorless it was. You know, 180 pounds on Earth, but only 30 there. Solar panels, experiments left, lunar landing module. You got to blast off and get back to your command module or orbiting module to take you home. Hopefully it all works. Oh, I don't see stars. It must be fake. If they were going to fake it, they'd put stars up there, right? Oh, moon's flag's waving. No, it's not. It doesn't wave. And you can read about that or whatever. But just don't. How cool would that be? Really, I mean, I want to drive that rover. It's the commander, has the red stripe. And you can study and get to know. It's kind of fun with binoculars to notice different things. And so here's a contrast of worlds. I would love to go to moon, not Mars, not me, but someone else. Look up and see Earth. 4 times wider that way, 4 times wider. So 4 more than a full moon to see Earth. And then you see things changing, like the clouds going and stuff, and you go, man, that's a pretty happening place. I want to go there. This is kind of boring, right? I mean, but what a view you'd have. If you put telescopes out here, then you can see stars very well because you don't have the atmosphere blocking you. So having an observatory, studying how the human body reacts, all that stuff can be done in an interesting way. Oops. Ways of going back. Here's a prototype. It's kind of a prototype RV for cruising around on moon. And the idea is you would crawl into your spacesuit, go out, get very dusty, so you don't want to bring that dust inside, back up here, and then crawl out of your spacesuit. Clearly, this is not on moon. If someone said that was on moon, yes, that would be a hoax. Pretty cool. That was going to go up in 2019, but economics and etc. We know where moon came from, obviously an artist's conception of something half as wide as Earth, the size of Mars, hitting and going into pieces and all that stuff, so we know the origin. So all this stuff is available. Think about it, Terminator, right? Think about Galileo. Think about the size. Moon being 4 times less wide, less hot stuff, less radioactive stuff, it's going to have cooled, right? Quite rapidly. And so we have what we have. And boy, that's a really good understanding. There's one image, here's another more recent image, outer core partial melt maybe, some radioactive stuff. But look at the mantle, it's mostly a dead rock, right? So you could look at all these images and they're pretty cool, and you can look at it through binoculars, and it's pretty fun until you get to that and they go, don't look at that. Oh, that was horrible. You can go back if you want. Oh, it was colorized. It was colorized. Why did we colorize it? You don't need color. It makes it look like an ocean. I always asked, what are the Maria? Were they ever oceans of water? No. Are they oceans? No. They're lava that seeped up, quickly solidified and dried. And that's what the Maria are. That's the story of our moon. Now we're going to talk about the story of our whole solar system. Where did it come from? What are the basic steps? How does a star get born with little bits of grains of sand with their little worlds around them where there might be life? And so we'll get our first taste of the birth of a star and a solar system by looking at our own, the one that we can study closely. And that is chapter 7. Then you'll also get to know what's in our solar system from sun out, and then also how wide, because you see how big a difference that makes. How big are these worlds, and how far away? You get farther and farther away from sun, you're going to get colder and colder. It's easier to hold the gas. You get closer and closer, hotter and hotter, harder to hold an atmosphere. So we'll study these worlds. Coming right up. Cheers, repetition, you got this.